The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
Mitsubishi.
I'm going with a dry rub. The only way to go, dry rub.
Dry rub.
Kansas City.
Okay. I like Texas dry rub.
Yeah, dry was good. Paul, what about you?
It doesn't matter.
It doesn't matter what your answer is. Okay.
I just don't like it with sauce on it. I just like it the way it is. I don't really like sauce.
On the side?
Just plain
No,
salt,
not even on the side.
salt and pepper.
I like the flavor without the sauce.
Yeah, I like a dry rub. First dry rub I have.
What's included in the dry rub?
Spices?
Spices.
Yeah.
Pepper.
Pepper.
Paprika.
Yeah. Cayenne pepper.
Okay.
Yeah. Good dry rub.
So, but what kind of meat do you? I mean, I like the I like ribs or the brisket.
Well, wait. I was at a place called, I'll tell you later, in Kansas City, and I had lamb ribs, and at the end of it, the flavor of the lamb just came right in. It was amazing. You know what was the killer there? The cream corn. The best in the world. Cream corn.
I'm not crazy about cream.
They were mine until I ate
like
the cream
cornbread.
No, give me the brisket. Give me the burnt ends.
Yeah.
Burnt ends with mac and cheese. Now we're talking.
I like the cornbread.
Yep.
Corn.
All right.
I think I just gained 2 pounds. Hello, everyone. Welcome to the METUS Tech Show.
So, Roland and Paul, thank you for joining us today.
Thank you for having me, guys.
Okay, so, what is the topic on this one?
Today, we're going to talk about the best piping practices.
Okay. So, going into this, we had a discussion. We discussed this in our training, and we really spent a lot of time in showing or relating how important it is to handle the refrigerant piping properly. Because we know that 3 of the major causes of compressor failures are moisture, lack of lubrication, and debris. And so this podcast should prevent that from happening.
Or at least we get across the importance of keeping a tight, clean, dry system.
Yeah.
That's huge because you're just like if your arteries were clogged, your heart's going to give out after a while. And we all know the compressor's the heart of the system. If you get anything in there that it shouldn't be in there, the compressor's going to stop. So we don't want to give that system a heart attack.
And I've seen people stocking pipe in their vehicles and, just completely kicking around, opened, just unprotected.
So let's talk about the kind of pipe, Roland. What should we be using when we're installing any refrigeration system?
Well, we got choices of soft drawn and hard drawn, but all the pipes should be labeled right on it, HCR tubing. That's it. That's the only thing we use for any type of refrigeration connection.
And ACR stands for air conditioner refrigeration piping, which is specifically for that type of application.
Absolutely.
And it's cleaned, and it's sealed, and
It's dehydrated.
It's dehydrated, and it's important it stays sealed until you're ready to connect it to the system.
So we shouldn't be using plumbing copper.
No, absolutely not. No, for many reasons.
Because I've seen that happen before.
No, we can't use that.
Okay. So, what about the piping when we install it? They both should be insulated, correct?
Yes.
Absolutely. With the correct size insulation on it, by the way.
Yes.
I've seen pipes with the wrong size and condensation just ends up draining on the outside of that pipe to the lowest point.
Yeah, and different parts of the country have different codes for the thickness
that's
of
right.
that insulation. And it's worth mentioning that they have to be insulated individually. I've seen cases where people will put the 2 pipes together,
In the same insulation.
insulate them both together, and now we obviously that creates a heat exchanger. We don't want that.
Yeah.
And what has been the experience of you two gentlemen on using copper tubing or line sets with flares already in them? Because, my installers don't make correct flares, and they don't want to have to take the time to do so.
Well, I think that as far as the flare nuts are concerned, we typically like to use a matched flare nut off the piece of equipment.
Okay.
I'm not saying that those flares on those pre-flared tubings aren't perfect. They probably are, but it's more so on the flare nut is what we're concerned about.
Yeah. And our equipment does come with flare nuts.
Right. If you look at the flare nut that comes on a pre-flared line set, and you compare that to the flare nut that comes with the equipment, use the one that's thicker, that's meatier, that's stronger.
Right.
Use that one. If the thin one is on the line set, absolutely cut it off and make your own flare. And and flaring, I think, has a stigmatism with it. People think, I stink at flaring, but there are tools out there now. I'm not going to mention any of the manufacturers, but there are plenty of tools out there. They make a perfect flare every time. It deburrs the end of the pipe for you. They're really, what's the word I'm looking for? They're idiot proof.
Right.
Can I say idiot proof?
Yeah, but just don't look at me when you say it.
I'm sorry.
We both looked at Roland when you said that.
I've known you a long time. It's just a habit.
Oh my God! I'm a victim of circumstance.
We were just wondering if you improved any.
Yeah, and as far as the flare nuts are concerned, too, I've actually taken a look at two of them side by side one time, and I was like, "Holy cow! There's a major, not a little different. There's a major difference between the two." And the thing about flaring, once again, you can get all the fancy flaring tools you want, but it's just prep. It's just prepping that pipe and taking your time. And I always say to, back when I was a boss, I used to always tell my guys, if you don't look at that flare and say, that's perfect, okay? If you say, yeah, it's pretty darn good, I could have, the minute that hesitation comes in there, cut it out. Do another one.
Yeah.
Right.
And the bottom line is that's your final connection in some case. You got to make sure it's right.
Yeah, and if you do it right, it won't leak.
Right. Yeah. One thing that I'm finding a lot of confusion in our classes is when we talk about line set that come pre-flared and they come with that red cap. And they think, when I asked the group in the class, I asked them, well, what is that red plug for? And most of the answers I get are, well, that's what keeps the trash and the humidity from going in the cap, in the copper pipe. And I tell them, no, that's the purpose of that red cap or plug is to protect the threads of the flare nut. Mm-hmm. Because if you remove that red plug and you look inside the flare, you will see there's a rubber plug inserted inside the copper tube. So if you're thinking that red plug is what that rubber plug is doing, you're going to leave that rubber plug in there. You're going to make the connection. You're going to start the equipment, and that rubber plug is going to end up somewhere in the system, probably at a strainer.
I want to talk about those threads for a second because I've seen people out there actually use like pipe dope on the threads. So on a flare fitting, where is the actual seal?
At the flare.
Between the brass and the copper.
Correct.
Right? So is there any reason why anybody should be putting any type of pipe dope on the threads?
Absolutely not.
Absolutely not.
No, I agree. Absolutely not.
There's
Absolutely
no need.
not.
If it's leaking, and you guys have mentioned it, if it's leaking, it's due to a bad flare.
Right. Yeah. The threads just hold the flare nut there. That's not where the seal is. The seal is where the flared copper meets the brass fitting.
And another good practice, what I do is when I line up my flare onto the unit, I'll hold it with my hand, and I won't have a tool at the time, but I'll kind of hold that centered right on that, and as much as I can, I'll hand tighten that before I put a couple wrenches on that.
But we should be putting a dab of refrigeration oil on that.
Absolutely.
Because what happens is when you've got two dissimilar metals touching each other, what are you creating? You're creating corrosion.
Yeah,
and on top of that oil creates a hydrostatic seal, which helps prevent a leak, which is what we're talking about.
You're talking the oil, a little bit of oil where the flare, the copper meets the brass again, right? What about oil on the backside of the flare where the flare nut's going to be
the same thing?
Same thing, yeah.
That prevents it from twisting. I can't tell you how many times in the 3 decades I've been doing this that, especially early on as a young apprentice, I'm going to tighten a flare nut and the whole copper line twists.
Yep.
So what do you do?
Because it's drying.
Yeah, so what do? You back it off until it untwists and just pray for the best. So that's not the right way to do it.
Yeah.
The oil on the back of the flare where the nut meets the copper.
And that makes sense because that's another brass to copper connection, which is going to create corrosion, and it's a dry seal, and it's going to leak, more than likely.
Yeah, so let's talk about prepping the tubing to make a flare.
Okay.
So obviously, if you're doing soft drawn tubing, I'll talk about soft drawn tubing. A lot of times I see people out there just torque down on their tube cutter. Nice and easy. Quarter turn, make 4 or 5 revolutions, quarter turn, 4 or 5 revolutions, because you really diminish the size of that on soft drawn tubing. And, make sure you ream it out, get all the burrs out of that. I know that I have a very fine file that after I burr it, I'll just file the top off, just to smooth it off a little bit. Sometimes you'll see it kind of looks like a little rough when the flare is done. Deburr it. If I didn't do that, sometimes you take a real close look at it. Almost looks like there's a little bit of a gasket, copper gasket on the inside. So again, everything in order to make a perfect flare, you got to perfectly prep the flare. Okay, and then once again, if you have a gauge on your flaring block for your height, or if you have an older block where you're using the old, a nickel or a dime, depending on the size of it, obviously you know what the gauges are, the height is, and then just compare that to the flare. Slide it. At no time should that flare thread down to the bottom of it. It should just kind of touch each one of the grooves as it's coming up, and looking down the bottom, make sure it's covering most of that shiny beveled part on the flare nut.
Right.
Prepping is everything.
Yeah.
And Paul, talking about flares, what has been your experience in using flaring tools?
The flaring tools, it has to be the right flaring tool. There are flaring tools that are made specifically for 410A refrigerant. Mm-hmm. And as I mentioned, there are flaring tools out there that now make it so easy that you have to actually work harder to make a bad flare than to make a good flare.
Absolutely.
If you want to find a good flaring tool, go to MitsubishiComfort.com, find a distributor. All of our distributors carry flaring tools. They carry all kinds of tools, torque wrenches, nitrogen gauges, nitrogen gauges for the tanks and stuff. They carry everything. But they have the tools that you need. But like anything else in our industry, the right tool for the right job. I've got flares out there, and I know there's a lot of our audience out there have flares that have been there for decades that just have not leaked.
Right.
That's because they were done right. Yeah,
Right.
absolutely.
If you do it right the first time, it's going to last.
Yeah.
Now, still talking about the flaring tool, I like the ones with the clutch. So we don't know our own strength.
Right.
And typically, you get a young technician, and they're thinking, well, the harder I torque it, the better it is. But what they don't understand is that what's going on, you're thinning that copper. So once you attach it to the brass fitting and you tighten the flare nut, then you're cracking the tube.
Yeah.
And there's your leak.
And thinning it is weakening it.
Exactly.
And it will crack. And, we've all had that happen.
And if it leaks, then what they'll do is they'll go to their truck and get a 24-inch crescent wrench and a 3-foot pry bar, and they'll stand on it, hoping that it'll stop the leak.
Well, let's talk about that. Let's talk about that. So,
Yes.
so when do you know you have the flare nut tightened enough? How do we do that?
There's only one way.
Yep. MyLinkDrive.com. It's all in the literature. You got to go with a torque wrench.
A torque wrench to the proper setting for the proper size flare nut.
Found in the installation instructions.
And when it clicks, stop turning.
Yes.
That's right. And everything should be double wrenched.
Use a backup wrench.
Yeah, backup wrench all the time.
So we've talked about the flaring tool. We've talked about using refrigeration oil. We've talked about tightening with a torque wrench. When it comes to bracing, let's talk a little bit about bracing. What should we look for regarding bracing? What should be done?
Well, the most important thing is that we don't have oxidation inside the system. There's only two things we want to see inside the refrigerant pipe. And I know I'm getting ahead of myself, but after we do the evacuation, we just want to see the refrigerant and the oil that comes with that refrigerant that's made specifically for that refrigerant inside the system. So we've all brazed pipe, and you see the oxidation, those black flakes on the outside of the pipe. That the same thing happens inside the pipe. Right. And then 410A specifically will come along and scrub that right off the pipe. It'll
clean
be
it
nice
right
and
off.
clean.
Yep.
And we have strainers in our systems, and now you're looking for a restriction. Now you're clogging that up. So we need to remove the oxygen from inside that pipe when we're brazing. So we flow nitrogen.
It's funny because I don't know how many years ago it was and how long ago it was, but I remember seeing the first cutaway of a 90-degree copper tubing used with nitrogen inside during the brazing process and used without. And I looked at that and I was just so amazed at the difference of how clean it was. Spotless. The inside of the 90 cut in half used in nitrogen was spotless, absolutely spotless. And the other one was, I couldn't believe it. And I think that back in the old days, we were all there. I think the compensation that we used was called a filter dryer.
Right.
So we used that and to actually correct our mistake. And if you look back nowadays, if you did what you were supposed to do then, that we are recommending that you do now, you didn't even need a filter dryer back in those days because it would have been a dry system. And with nitrogen, those inside those pipes are clean as a whistle.
Yeah, with R22, it wasn't as big a problem as it is with 410A. That 410A actually scrubs the inside of the pipe. It's going to make it nice and shiny and clean. Where with 22, hey, maybe some of those oxidation stays on the pipe inside. But we need to flow nitrogen anytime that we're brazing, putting a torch on there. Nitrogen removes the oxygen. Without oxygen, we cannot have oxidation.
Yeah, and just to clarify on that, so we're running nitrogen through a pipe. You may read a lot of times they'll say 1 to 3 psi. That 1 to 3 psi that they're talking about is at the regulator. It's what your regulator is set for because you should have no pressure in there because one of the ends of the pipe is open.
Just barely flowing.
It's just a breeze. But so when you see that 1 to 3, don't get confused with it. It's just what's set at the regulator.
It's 1 to 3 flowing. We don't want any pressure built up where it's going to throw the filler metal right back at you.
At 1150 degrees. Would you agree that's hot?
It hurts a little.
Yeah, sure. We'll say that's hot. Yeah.
And while we're talking about preparing the copper tubing, we talked about cutting the flare nuts. And every time you cut copper, you create a lip inside that copper tube, and we need to remove that lip. We call that deburring. So to remove that burr, we use a reamer, and then what do we need? We need to be careful where that burr goes.
Absolutely.
So we make sure that we don't introduce that debris inside the pipe, right?
Right. As you mentioned, that's one of the causes of compressor failures, And we have had compressors that we have taken and taken apart, and we found sand and sawdust and copper shavings. And imagine copper shavings getting into the compressor and going on the windings. What do you think is going to happen there?
Because it's going to start shorting things out.
Exactly. So
and that's also friction in the inside of the housing, whether it's a rotor or you reciprocate and scroll. That's also going to be abrasive, and that's going to start scoring up the cylinder walls as well.
Right. And why are we finding sawdust and sand and gravel inside our compressors?
Tracking the pipe through the back
the job site.
Right. So the other thing is that pipe has to be sealed. ACR comes sealed on both ends. It stays sealed until you're ready to make that final connection.
Yeah, and in commercial applications, we see a lot, even residential down in Florida, we see a lot of pipes that ran underground.
That are roughed in. And then they're left open.
And left like that for a while.
Only God knows what goes in it.
And it's common to go in and rough a building, whether it's commercial or residential. You got the pipe sticking up through the roof. It's sitting there. And I've seen it many times on different job sites where somebody just puts a little bit of electrical tape.
Yeah.
It's outside. It's facing up. Now the rain, the weather, the elements gets in there. So please, folks, seal that pipe until it's ready to make that connection.
Either cap it if it's hard pipe, or if it's soft copper, you can pinch it and brace it.
Right.
Just seal it.
Exactly. It's sealed to keep all the junk out. Again, what are the two things we want to see inside the refrigerant pipe?
Refrigerant and oil.
And that is it.
Nothing more.
That's it.
And again, being careful to make sure that no rubber plugs remain inside that copper tube.
So what about some additives? What about other additives that different people use to find leaks or make sure that
those are no-nos.
Those are no-nos.
Yeah, that's what we're going to talk about next.
Right.
What we don't want to use. So we have things that we don't want to see in the system, as Paul was saying. So on those were what? What are some of the things that we don't want to see inside the system?
We don't want to see anything inside the system other than refrigerant and the oil. That's the oil specifically designed for that refrigerant. We don't want to see little pieces of solder in there. We don't want to see sawdust. We don't want to see sand. We don't want to see anything in there. Oh, and one thing too, we don't want to see the rubber plugs, the plugs that come in the ACR. We've seen people put couplings on there.
But the other thing we don't want to see in there is some of the things we don't use anymore are sight glasses. Like we don't, back in the day, the R22 day, it was standard practice to have a sight glass mounted right to the filter dryer.
Right.
And then even some of them I'd braze them in, some of them I'd actually get flared. It all depends on what I was doing at the time. Especially if I was up on a roof and I didn't want to haul up a tank, I'd get the flare one. It was the easier thing to carry up the roof. But we don't use those anymore at all.
No sight glasses.
No sight glasses.
no filter dries.
No,
No filter
Also, don't use soft solder.
no, absolutely not.
Because for us to use soft solder, we have to use flux, and where does the flux end up?
Right.
Inside
Inside
the
the
pipe,
system.
Absolutely.
and that's a no-no.
Now, a lot of people think that we don't use soft solder because of the pressure, but that has nothing to do with it. Because Stay Bright will handle those pressures, but it has flux in it, so that's a no-no. It's got to be brazed. You got to braze.
And even I'll just back up. We kind of might have missed this, but I still prep my pipe the same way I would if I was using flux. I still sand it, clean it, because I got oxidation on it.
Yep.
And I'll, once again, back to debris inside the pipe.
Yep.
When I'm reaming the pipe and sanding the pipe, I hold it facing down.
Absolutely.
And if I can't, I'm going to take a dry rag, something that's doesn't have a lot of fibers on it, wipe it off. And then the other thing too is that if I did have a lot of horizontal prep pipe, I was going to do, I'm going to blow it out with nitrogen before I actually have the nitrogen set up for 1 to 3 psi for brazing. Right. But another good point there too.
Yeah, many times in our classes we get asked, "Well, how about P-traps?"
Well, there's the industry standard rules or rules of thumb, whatever you want to call it, where for every certain feet of rise, you would put a trap in there for oil return. But with the Mitsubishi systems, we don't require that. Right. If you pipe it properly, if you don't exceed the maximum distances, if you don't exceed the maximum rises, then the oil will return. If you use the right pipe size, the oil will return. So there's no need for those traps. That industry standard.
Right. Yeah. Right. Limitation, separation. Stay, once again, stay within the confines that you're supposed to, and traps aren't needed. Yeah.
Now, regarding leak testing with additives like dye to find the leak, when I was in tech support, I used to get the call, Juan, I'm going on a job site, and I know I've got a leak in it. And I asked, well, how do you know you got a leak in it? And I said, well, I'm having to put refrigerant in it every so often. And I said, well, and they would tell me, I can't find the leak. And my first question was, what are you pressurizing up to do the leak testing? And guess what answers I would get? 250, 300, 350 pounds.
Oh, I've even gotten less than that, 100, 75 pounds.
Yeah, and then you're not going to find a small leak with those pressures. And that's why we as a company recommend going up to 600 psi, which then will find a pinhole as a leak. And that's why we don't recommend any dyes, any additives to find a leak. There's a proper way of doing so.
Look, all of us, I'm sorry, Roland, I didn't mean to step on you, but all of us have had those leaks that are hard to find. You just got to put in the time. A worst case scenario, I would never recommend putting any of those dyes where you take an ultraviolet light and they come up a different color. And a little quick side note, I did that once as a young technician in the field.
I have too.
And it was a system back when we were using Stay Bright, and come to find out, all the flux glows green.
Yep.
So I had a leak, or at least I thought I did. But, worst case scenario, I'll isolate this system. If I've got multiple indoor units, I may isolate the indoor units and the line set and the outdoor unit, and I'm going to pressurize them all and see where I lose that nitrogen. Worst case, if I had a leak that was one of those hard to find.
Right, and I think that in the commercial end of it with the branch box systems, a branch controller, if it's on the commercial branch box, if it's on the M&P side, you can actually fill that all up with, say, 600 psi of nitrogen, and then you can shut all your valves off. So when you come in, you're going to lose a little bit of pressure because you're moving your gauges around. But if you go to one branch connection and it's 595 psi, another one's 597 psi, then all of a sudden you hit one at 300 psi, you're isolated to that one circuit. And, it's a smart thing to do as well.
So now we have shown how critical proper or best piping practices are to an installation, because it's all about the installation. The installation is where most of the problems are created.
It's the most important day or days, the most important time in the life of the system.
On the job,
Absolutely.
Installed.
So there's two areas that we need to always keep in mind as well when it comes to the proper installation, and that's the areas that I'm going to mention are found in the installation instructions. One being following piping limitations. Why do we have piping limitations?
That's to ensure oil return and proper operation.
Yes.
Yeah, absolutely.
And then the other one is following vertical separation.
That's the same thing. We want to make sure the oil return gets to the compressor, and those separations are going to be different whether the compressor is above or below the indoor units or the branch box. So we can't exceed that. Roland, where's the only place we really need the oil?
It's in the compressor.
That's it.
Absolutely.
It's the only place we really
The only
need it.
place it belongs.
It's the only place we need it.
So to help us with all that, with piping limitations and vertical separation, is there something at our disposal that we can use, Roland?
Yeah. Listen, people out there. We have a free software program for you in mylinkdrive.com. It's called Diamond System Builder. We call it DSB. Diamond System Builder on that vertical separation, on piping limitations. It's going to show you whether or not you've gone over. Once again, if you did go over, you're going to have a round red circle with a line going through it. So you're going to know right off the bat that you need to make some changes, some sort of altercation to stay within those limitations. So Diamond System Builder, you got to go to it.
You know what my favorite thing about Diamond System Builder is, Roland?
It's free.
No, besides that.
Oh, no.
It tells me how much refrigerant I need to add without me having to do math.
Exactly.
And you know that math is my weakness.
Well, your weakness?
Mine
You should
too.
talk to Juan about
Mine
this.
too. I run out of fingers on toes.
The shoes come right off.
You know
All
what
right.
my favorite thing about this podcast has been?
You're learning math?
No.
Oh.
Not being able to cough. Yet I started to cough.
Well, listen, we're in a cold climate right now. It's
I know.
okay. All right.
It happens.
Yeah.
So here's what I would like for the three of us to do. Our last tagline is keep it clean, tight, and dry. I would like for the three of us to do it in unison. Can we do that?
I don't know what you want me to do here. I'm confused.
We're going to say keep it clean, tight, and dry at the same time. You ready?
Ready?
All right.
1,
2.
2, 3.
Keep it clean, tight, and dry.
Wait, is that the end of the show?
Yeah.
We're over?